Hello. Yes, we welcome you back to our channel, PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Today we are looking at this question. It comes from Projectile. The question reads that a hot air balloon is moving vertically at constant speed. A camera is accidentally dropped from the balloon at a height of 92.4 meters, as shown below. The camera strikes the ground after 6 seconds. They say ignore effects of friction. So what we are having here is the diagram to illustrate what is here. We are having the balloon, somebody's inside the balloon. The height is indicated 92.4 meters. And the balloon is going upwards at constant velocity VI. Okay? Then the question comes, it says that at the instant the camera is dropped, it moves upwards. Give a reason. What actually is happening is that somebody is inside the balloon, which is going upwards, and somebody is dropping the camera. So ideally, we would expect the camera to be going downwards. But they say the camera initially goes upwards. Why? The reason is that the camera, because it is inside, it's coming from inside the balloon, it takes up the velocity of the balloon. And the velocity of the balloon is VI and upwards. So initially, the camera will go upwards. Yeah, now we come to this question. Question B. It says that calculate the speed at which the balloon is rising when the camera is dropped. Yes. What is the speed? How do you determine it? Okay, the best approach here is to go back to our illustration, and we get the trajectory, the path which was taken by the camera. So when the camera is dropped, we said it rose upwards, reached maximum height, then dropped and struck the ground. Okay, so let us look at what we have. So from here, we look at the data, the information. So what do we have? We are looking for VI. We don't know it, the initial velocity. But we know time it was given. Time is 6 seconds. Okay. So what else do we know? We know displacement. Displacement requires some bit of attention here. I want you to remember that it rose upwards, reached maximum height, then came down and struck the ground. So from here, you have to understand that what you have here is the displacement. Why? You have to remember that in this part of the path, the camera rose and dropped the same displacement. So they are equal and they cancel, leaving us with this one as the only displacement covered by the camera. So we have it, and our displacement is that. But there's something trick about it. You have to remember that we took upward positive, and our displacement is below point of projection. So under that circumstance, if the displacement is below point of projection and you took upward positive, the displacement is negative. So our displacement is going to be negative 92.4 meters. Okay, what else do we know? We know G is projectile. Yes, G, which is acceleration due to gravity, is 9.8 meters per second squared. But you have to remember here that we took upward positive, and G is always acting downwards. So that means that our G is going to be negative 9.8 meters per second squared. So that is the data, that's the information we have. And now that you have the information, what do? We look for the right equation. The equation which can incorporate all this we have. And the best equation is delta x equals to vi delta t plus a half a delta t squared, which some people call third equation of motion. So after the equation, what do? We substitute. Okay, yeah, we have delta x. Our delta x is negative 92.4. Okay, yes, vi we don't know it. It's what we are determining, but we know t. Delta t is 6. Then what else do we have? So here we have a half times. A is the same as g, which is acceleration due to gravity, and it is negative 9.8. Then times delta t squared, and delta t is 6 squared. So that's the information we have. So let's see what we get out of this. Yeah, so from here we have this. And what do? At this point, what do? We collect like terms. You have to remember that this one's like, and this one is like to this one because they are known, and this one's unknown. So the best alternative is to bring this one this side, and when it comes this side, it becomes positive. Yeah, so this is what we have. And from here, what do we get? From this side, we have 84, which is equal to 6 VI. So what do we do here? We determine VI by dividing both sides by 6. So what do we get here? We are going to get our VI as 14 meters per second. Yeah, then we come to this question here. It says that draw a sketch of velocity time graph for the entire motion of the camera. So how do you go about this? Yeah, so the question wants us to draw the sketch of velocity time graph. So on this axis, we have the velocity in meters per second. And on the x-axis, we have time in seconds. Okay. And how would the sketch be like? We have to go back to our trajectory. This is how the camera moved. It moved upwards first. So it executed two motions, very important motion. It moved upward like here. Okay. And when it's moving upwards, how do we show it? We are going to show it upward motion is indicated like this. You have to remember that as it goes upwards, the velocity decreases until it reaches maximum height when the velocity is 0. So that one is indicated by this. Okay, so this is upwards till it reaches maximum height. What do we say maximum height? The number here is 0. Maximum height implies 0 velocity. So then we have to go to the second motion. Now it moves from maximum height up to the ground. And that's what we are going to put here. So this one is from maximum height until it strikes the ground. So you have to show it here. Yeah, that's the sketch. And what information do we have on the sketch? This is what you have to remember, that whatever we have here, it is the initial velocity of projection. We have to remember that the camera took up the velocity of the balloon, which we found as 14. So the number here is going to be 14 meters per second. Okay? And what else do we have? We have the time of projection, the time to cover the entire motion, the time from point of projection till it strikes the ground, and that is 6 seconds. You have to remember that obviously when you look at these two motions, this one is smaller than this. That's why you see this one is longer. So the time is indicated. Suppose this is the time when it strikes the ground. So this time is known, and it is 6 seconds. So that is our sketch.